Hello, good day. This is Dave Kome, and welcome to K2 Concept YouTube channel. And today I'm going to be taking you all on a journey into the world of operational research. And basically, we're going to be handling what we call an LPP problem, which is known as the linear programming problem. And we're going to be applying the algebraic method to solve this LPP problem. Although we have other methods of solving LPP problem, such as the graphical method, the simplest method, the big M method, the two-phase method. But today, basically, we're going to be handling the algebraic method of solving the LPP problem. And this is a very good example of an LPP problem, but a minimization type. A minimization type having two constraints, and the constraints are greater than or equal to constraint. We can still have a problem where this constraint might be a less than or equal to constraint. Take note of that. It's also an LPP. You can have the one of equality constraint. Now, we have two types of variables we introduce in an LPP problem. The first one is what we call the surplus variable. The second is what we call the slack variable. Now, the surplus variable is introduced when we have a greater than or equal to at the constraint. Then when we have less than or equal to, we introduce what we call the slack variable. And when we have equality constraint, we introduce the artificial variable. Now, to solve this problem, take note of this, to solve this problem, it's very easy to solve this problem. We have to convert this problem first to what we call an LPP problem. An LPP problem. Now, the LPP problem we're talking about is to change these constraints to equality constraint, that is minimize 10x1 plus x2 subject to 3x1 plus 3x2. Now, since it's greater than or equal to, I will subtract the slack variable. I will introduce, let's say, x3. Let's say x3, for example, then equal to 21. Then 4x1 plus 3x2 minus x4 equal to 24. Now, the non-negative constraint will be x1, x2, x3, x4 greater than or equal to 0. Now, to solve this problem using the algebraic method, the first thing we have to understand is this is the headings you need: the number, the basic variable, non-basic variable, the solution, the objective function, and the types of solution. Take note of that. These are the things you need. But the question is, how do we obtain all these things that we have here? How do we know our basic variable, our non-basic variable? Now take note, our basic variable are the variables we intend to solve for, while the non-basic variable are the variables we intend to fix to be equal to 0. Then the solution is the solution, the result or the value of our basic variable is known as our solution. Then the objective function value is the solution of the basic variable if substituted back into the objective function. Then the result we obtain is the value of our objective function. Then the type of solution can either be two. Is that it is a feasible solution or non-feasible solution. Take note of that. Non-feasible solution exists when the solution of the basic variable are negative. If one of them is negative or both, then the solution type will be a non-feasible solution. But if it is positive or 0, then it is what? A feasible solution. Now, to start with, there is something we need to understand is we have to know that this problem have only 4 unknowns. 4 unknowns, which you can represent as m. Then we have 2 equations, which is n. Now, these unknowns and equation, to get the number of variables we have to solve for, we use m minus n. Take note of that. That's unknown minus equation, which will give us 4 minus 2, which is 2. And also to know the number of combinations of solutions we can get, we apply the concept of combination, m combination m, which is m factorial over m minus n factorial n factorial. Our m here is 4. Our m is 4 minus n, which is 2, then 2 factorial. At the end of the day, we're going to have 4 factorial over 2 factorial, 2 factorial. Then we have 4 factorial over 2 factorial. Then this is 2 times 3 times 2 factorial, because we know that there is 2 factorial here, so we end it at this stage so that this can cancel out. Then we are left with 4 times 3 over 2 times 1. 2 here, 1, 2 here, 2, which is 2 times 3 here will give us what? 6. So we're going to have possibly 10 combinations, which will go back to what we are having here. First one here is 1, which is 2, 3, 4, 5, 6, because of the result we obtain. So if we were to work with 5 unknowns and 2 equations, it will be 5 minus 3, which will give us what? 2 also. Then we do the combination. It tells us that we're going to have 10 combinations. That's 10 possible solutions. Now, how do we get this? How do we get this? To get this, the first thing we have to understand is we have to fix x1 and x2. Let's say we are solving for x1 and x2, then x3 equals to x4 equals to 0 is fixed. Then let's assume that x1 and x3 want to solve for the both, then x2 and x4 are fixed to be equals to 0. Then x1 and x4, then x2 equal to x3, both equals to 0. Then we also consider x2 and x3, then x1 is equal to x4, both equals to 0. Then we'll consider a situation in which x2 and x4 are what we want to solve for, then x1, x3, both equals to 0. Then we'll consider lastly x3 and x4, then x1 equals to x2 equals to 0. Now with this, we can get the solution, the objective function, and the type of solution rather we have. So now let's go back to the problem we have. If we go back to the problem we have, we observe clearly that the equations we are having is 3x one plus 3x2 minus x3 equal 21, and 4x1 plus 3x2 minus x4 equals to 24. Now going with the first type of solution that we have here, that is when we fix x3 and x4 both equal to 0. So it means if I fix x3 and x4 equals to 0, these two are out of the equation. Then I'm left with 3x1, 3x2 equals 21, 4x1, 3x2 equals to 24. And applying elimination method of solving simultaneous equation, I'm left with minus x1, I'm left with minus 3, therefore x equal to 3. Then put x1 equals to 3 into either equation star or equation star star so as to solve for x3. So this 3x1 plus 3x2 equal 21. 3 into 3 plus 3 x2 equal 21. 9 plus 3 x2 equals 21. Then 3x2 equals 21 minus 9. 3x2 here will give us 12. Then x2 will be 12 over 3, which is 4. That's how we obtain the value of x2. So we'll go back to our table. It means the solution x1 is equal to 3 and x2 is equals to 4. Then the objective function can be obtained very easy. To obtain the objective function is to go back to the objective function given to us, which is 10x1 plus x2. Remember, we can still add the slack variable there. We can still add the slack variable, which is 0x3 plus 0x4. It has no effect. So if I impute that into what I'm having here, it means 10x1 plus 9x2 plus 0x3 is 0x4. And we know that this is 10 into 3, 9 into 4. And everything here is 0. Here it's 30 plus 36 give us 66. So the solution here, or the objective function value here, is 66. And we know the type of solution here will be what? A feasible solution. So we'll go to the next one also, which is fixing x2 and x4 equal to 0. If we fix x2 and x4, we'll go back to the equation plus 3x2 minus x3 equals to 24. Then 4x1 plus 3x2 minus x4 equal to 24. If we fix x2 and x4 equal to 0 at this stage, we observe that we're going to have 3x1 minus x3 equals to 21. Then 4s1 equal to 0, because x2 and x4 are fixed to be 0. So from here we can see clearly that 4x1 equals to 0 implies x1 equals to 0. So if x1 equals to 0, we put that into this equation. Let's call it equation star star star. So 3x1 minus x3 equals to 21. x1 is already 0, so it's 3 into 0 minus x3 equals to 21. So minus x3 equals to 21 implies x3 equals to minus 21. So it means I want to have our solution x1 equals to 0 and x3 equals to minus 21. Then imputing the objective function, this value into the objective function the way we did before, be 10 into our x1 is 0 plus 9 into minus 21 plus 0x3 plus 0x4. All these things are 0. Here is 0 minus, if you solve this problem very well, we have 9. Then here we have 18. That's minus 189. So at the end of the day, you have minus 189 as your answer. So the objective function is minus 189. And this is what? Non-feasible solution. I've explained that. Now we go back to the third one. The third one is saying that if we fix x2 and x3 equals to 0 and we solve for x1 and x4, we'll go back to our equation. Our equation is still the same. Don't forget, equals to 24. But at this stage now, we are making x2 and x3 equals to 0. That is, these two equals to 0. So this equation will reduce to 3x1, 21, 4x1 minus x4 equals to 24. Now call this one 1, here 2. Solving for x1. So x1 equals to 21 over 3, which is 7. Now put this into equation 2. So we have 4 into 7, because x1 is 7, minus x4 equals to 24. And you multiply this is 28 minus x4 equals to 24, which is 28 minus 24 x4, which is 4 equals to x4. And we can see that our x1 is 7 and our x4 is 4. And if you impute into the objective function as we did earlier, it will be 10x1 plus 9x2 plus 0x3 0x4. And our x1 is given to us as 7. Our x2 is 0. These other guys are 0 also, because x2 was what we fixed just now. So it will be what? 70. So at this stage here, we're having 70, and the solution is said to be what? A feasible solution. We'll continue with the same thing. We'll go to the fourth one when x1 and x4 are equal to 0, and we're solving for x2. 3x1 plus 3x2 minus x3 equals to 21. 4x1 3x2 minus x4 equals to 24. When we fix x1 and x4 equals to 0, we have 3x2 minus x3 equals to 21. These two equals to 0. We are left with 3x2 equals to 24. Solving with this one first, 2 from 2, we have 3x2 equals to 24. Then x2 equals to 24 divided by 3, which is 8. Then using back substitution, substitute into equation 1 to solve for x3. We have x3 equals to 21. 3 into 8, x3 21. 24 x3 21. 24 minus 21 equals to x3. Answer here becomes 3. So we'll go back. We know that our x2 is equals to 8 and our x3 is equals to 3. And if we substitute the both into our objective function, don't forget, I'll be doing the same thing. X1 is fixed to be 0 and x2 is obtained to be 8. X3 and x4 will be 0 irrespective of the value they are having. So here is 0, 0, which at the end of the day, if you multiply 9 times 8, we are going to have 72 at the end of the day. 72 at the end of the day. So here give us 72. Then we'll go back to the next problem. Remember, before we move further, this solution is also known as what? A feasible solution. The second to the last, we'll do the same thing at this stage now. At this stage, we are to fix x1 and x3 equals to 0 using the same condition. Don't forget. So if I'm to fix x1 and x3 equals to 0, so this one and this one will leave. I'm left with 3x2 equals to 21. Then x1 and x3, this one will leave from this equation. Then there's no x3 here, so I'm left with 3x2 minus x4 equals to 24. Solving this one first, 3x2 equals to 21. x2 equals to 21 over 3, which is 7. Then imputing into this equation 2 to solve for x4, be 3x2 x4 24. 3 into 7 x4 equals to 24, which will give us 21 minus x4 equals to 24. So we have 21 minus 24 equals to x4, and here is minus 3 equals to x4. So at this stage here, we have our x2 to be equals to 7 and our x4 to be equals to minus 3. And to get the objective function is to impute them back into 10x plus 0x4. And x1 is 0, x2 is 7, but x3 and x4 give us 0. So at the end of the day, this answer here, at the end of the day, if we solve it, will give us 63. If we solve it, will give us 63, and here will give us 63, which is also a non-feasible solution. We have explained that because of the negative value of our unknowns. That's why it is a feasible solution, non-feasible solution. Now we'll move on to the last case. The last case is x3 and x4. When we fix x1 and x2 equal to 0. So we have this 4x1 3x2 minus x4 equals to 24. If x1 and x2 are equals to 0, we have minus x3 equals to 24. Then here will give us, if this guy equals to 0, x1 and x2 equals to 0, we are left with minus x4 equals to 24. So if we solve this problem, we observe that x3 equals to minus 21 and x4 equals to minus 24. So x3 equals to minus 21, then x4 equal to minus 24. And if you substitute back into the function, which is the objective function, 10x1 plus 9x2, we have 10 into 0 plus 9 into 0. At the end of the day, we have what? 0 as our answer here. And this is a non-feasible solution. Now, we have to select our final answer among those that are feasible solutions. We have how many feasible solutions? We have 1, 2, 3, 1, 2, 3. Only 3 of them are feasible solutions. So, because it's a minimization type, take note, we are taking the minimum value of the objective function. If it was a maximization problem, we'll take the maximum value of the objective function that has a solution that is what? Feasible. So among the feasible, we have 66, we have 72 and 70, 72 and 70. But since it's a minimization type, our answer will be this optimal. So our value will be objective function equals to 66 at x1 equal to 3 and x2 equal to 4. So take note of that. This will be our final solution. Thank you for listening and thank you for watching. Once again, this is K2 Concept YouTube channel. Don't forget to subscribe on our YouTube channel. Don't forget to like, comment, and share. Thank you.